midterm and final exam. I will give the more information about the midterm and final exam. It's a fully online. Then I'm going to use a lockdown browser for your exam. So same time, so you are going to log on the Canvas, then you will take the exam. And final exam also. No attendance check this semester, and the grading policy, the distribution will be the adjusted based on your overall performance. Okay, so this is just for the syllabus, the information purpose. Practically, I'm going to give the curve in case it's too tough, or based on your performance, it will be adjusted. But usually, the middle range is around the B or B plus. That's my expectation. So this is the schedule by week. So last week we didn't have any class because of the adjustment of the academic schedule. So this is the second week. So we are going to start. So if you the due date is already marked on the assignment on Canvas, so you don't have to memorize. Right? But the board one is the exercise lab. So, but maybe the changes. So depending on the progress. So I will announce if. But what you guys need to do is bring your laptop or be ready. At home with the internet connection, as long as you join the Zoom, it's probably fine, because we are going to use the compute engine on GCP, the cloud computing. If you do not have any experience on the cloud, I will give some material, so maybe next week, so you can practice by yourself after you activate the Qton code. Otherwise, we are not going to use the computer engine, but the cloud computing. But nowadays, if you are interested in the machine learning or the AI, and I want to use the GPU, but I do not have the GPU machine, so you can create your the virtual machine on the cloud computing, then the practice. So there are a lot of services which is available for. The problem is the $50 is not enough to practice everything, but it's good for the operating system. Okay. Also, many of the students are struggling by using the command line editor like the VIM or the VI. So this is good time to practice. I think the 1 or 2 hours may be enough to start to learn the VI. There are a lot of the intermediate level or the advanced level of using the VI line editor, but you don't have to know everything right now. But for this class, I think the 1 or 2 hours may be enough. Then it is true. So even though VI is not practically used a lot in the educational system, but when you get a job after graduation, so a lot of systems still use the command line interface. So for example, Python, so you can use the Jupyter, or you can use the PyCharm, but a lot of the batch job or the server-side program is based on the Python shell. So it's a command line. At that time, if you are able to use a VI or the VIM command line editor, it's very convenient. So this is a good time to learn about the command line. So that is the VI and the Unix programming and so on. But this is my plan, but not sure whether I can cover each and every topic this semester. So I will try. And as you know, our in-person class will be ended before Thanksgiving. So after Thanksgiving, it will be fully online. But it may be possible, in case something happens in the middle of the semester, our class will move to the online and so on. Okay, so then all lecture notes are available on Canvas with the PDF format. So, but sometimes I update the PDF file. If in case I update the lecture note, I will replace as soon as possible. And okay, so let's start the lecture. I forgot to introduce myself. So my name is Jung-Yu Lee. You can call me the Lee or the Professor Lee, whatever. I'm professor of computer science, the department, and I've been here since 2006. And mostly I'm teaching the data-related topic, including the advanced database, the SQL database, data mining, and big data also. This semester, I'm going to teach operating system as well as the NoSQL database. So I have taught the operating system last 10 years, but stopped a couple of years before. Then again, I teach operating system. So whenever I teach operating system, I learn also a lot because for example, the last couple of years, so a lot of contents from the mobile operating system like the Android, iOS are added, and also the cloud computing and the virtual machine. But behind the still basic component of the operating system are not changing, which include the process, memory, and the file structure. So these are not, I don't think it will be changed soon. So unless we have the new computing, the architecture like the quantum computing, so please. So I spend the most of time this semester to introduce the how to manage the process, how to create the process, and how to manage the memory, and how to manage the file structure, and so on. And I'm doing the research also on such a data-related data analytics and so on. So if you're interested, so you can always, you are welcome. And also I'm in charge of the senior project for undergraduate student. So if you are in the senior project class, we will see again tomorrow using Zoom. Okay, so let's start. Yes, this is what I want. If you are ready to my class, you know the what does it mean? What is this one? So this is the from now on computer in my class. So I'd like to very briefly and high level the computing architecture as well as what is the operating system before we start the main part. So this is our computer. So we have the main component of this computer. One is the most important part is the CPU. So as you know, this is the main processing unit, central processing unit. Everybody knows. So nowadays there is a sibling of this one, which is called the GPU. So graphical processing unit. It's not only for the graphics. Nowadays it's used for huge computation, especially on the machine learning and AI. So we will see later this one. So what is the main purpose of the CPU? CPU can process the data. What kind of data? Or the information. So what kind of information? So computer is not that smart, basically. Computer can process only pre-design the information, which is called the instruction. It's in other words, it's a kind of command. There's a very basic command. So before we talk about what is the CPU, what is the processor, sometimes it's called the processor. So process what? It processes only the such an instruction. So what is the instruction? So when people design the computer, so what is the by the way computer? What is a computer? So computer is, so I usually compare with the teacher. So teacher is a person who teach. So this one is a person or a thing who can compute. So long time ago, really long time ago. So when the Homo sapiens is just the hunt, okay? They don't need a lot of calculation or something. So they can hunt, they can catch the animal or what they need for daily life or the monthly life, the whatever. But once they settle down for farming. So what is the main difference between the farming and the hunting life? So we have a lot of the things. When Homo sapiens are doing the hunting, they don't need the huge animal, because even they cannot keep for a year, they cannot keep several years. So instead, they can hunt only the amount that they need. But this story is different story. When they settle down, usually they settle down the delta area and the river, like the Nile River or Mesopotamia or the Ganges or the Yams. So because it's fertilized, so they can farm and they have the rice and a lot of the crop and even much bigger than what they need. Okay? So next thing, they have the more people coming because they have enough food and such a thing. Then when the Homo sapiens are doing the hunting, only few family group, like 10 maybe 20, but when they settle down for farming, it's 100,000, sometimes 10,000. So when they have such a huge number of people, so they need to control the people. So which is the starting of the government. But the government is not free service, so they need the money. So they can collect the money, which is a tax. So they need to calculate. So how much money we need to collect and what is so because A person, B person, their size of the farm is different. So we need to calculate. So from that, so we need something. It's not just the calculate with the finger. They need to this amount of area. So sometimes it's not just a rectangular shape. It can be the arbitrary shape. So how can they calculate? So it's the starting of the geometry. And they calculate the amount of money to pay for the government, like the tax. So they need a calculator. So for the computer. So like the oldest one, we usually call the abacus. Abacus is like the marble. Then I learned that in my math class. So when I was in the elementary school. So starting of the computer. However, such a computer is not the same as the computer we have. It's different. So what is the main difference? So we usually consider electricity. So electricity, electric computing device as a computer. So why electricity? So why we consider electricity to design the computer? So a long time before. Because electricity is easy to represent what? 0 or 1 using current, right? So we use this one. Why the 0 or 1? If we can represent, if we can use a 0 or 1, this is called a binary. Then using the binary, so we can represent any number. It can be decimal, it can be hexadecimal, and whatever. So we can represent any number. Not only the whole number, like the integer or the negative integer was 0, but also we can represent using scientific notation. So using the exponent, we can represent the float also. Whole number and the float. But number is not the only communication method for that. We are using natural languages like the English or Korean or the Japanese, Chinese. So how can we represent that? So we can have a code. The number versus the letter. So for example, ASCII. So ASCII code is the most popular, the code between the number and the letter. So we can represent the alphabet and number using what? The binary, 0 or 1. So electricity is good. The method to use to build such a computer. Then based on this one, so we can have the transistor. So long time before, who invented the bulb? Where is the bulb? At the bulb? Edison. So Edison actually so when I'm not in the electrical engineering, but if you know about the very basic the electrical engineering, so we have the voltage and we have what? Resistance. The resistance. So for example, this one. So if we put the resistance over here, then this current, then there's a line. The problem is spun up. So Edison actually put the vacuum. If there is no oxygen inside, it will be the line. So this is the idea of the verb. Then why not using such a thing? And to represent 0 or 1, we know that this current can represent the 0 or 1 easily, like this one. It's not clearly this, but almost the same. So if there is the light, we can put the switch. This is 1. Otherwise, the open, then it will be 0, like that. So by combining this one, then we can have the transistor. So transistor usually have the 3 legs. So if you see something Arduino or the design circuit project, you can see the 3 legs. The transistor. Transistor has a switch that represents 0 or 1. Then, if we have the 1011 binary number, we have the 4 transistor. And close, open, close, close. Then we can represent such a binary number. If we can represent a binary number, then we can represent what? So any number. And if we can represent any number, we can represent such a letter. Then that's it. So this is the very basic of computer, the system. Then people think about not only just representing the alphabet and what the number, but can we process such a thing? Like I try to add the number 1 0 1 1 1 1 1 1. Can we add this one? It's operation. Or substitute. Or sometimes the change. Whatever. So they actually design such a very basic command to be processed. It's a processing operation. Then design the circuit, the processing unit for the CPU. So like the Intel, they have the number of usually such a. Do you think how many the instruction or the command? So
The people in the online class that they can't see the right side of the board.
oh, I see. Sorry. So I'm going to use this one, the main. So thank you. So but that's not the major thing. Don't worry. So then, like the Intel, the company when they design the processor, how many instruction? How many command? It's like sometimes very few, the less than 10, but usually it's the less than 200. So no matter what types of computer you use, supercomputer or whatever, so such a very basic command for the operation are limited because they need to design in the hardware the CPU chip for such a processing. So such the command, if we are using such a command for the programming, so very low level programming like assembly. So if you are taking what is the name of class? 286?
Computer organization? Is it computer organization?
Computer organization, where you learn the assembly?
Well, that's microprocessor.
Microprocessor. So if you take the microprocessor class, so you learn about the 8-bit processor or 16-bit processor. Then the processor has a pre-designed such a operation, and this is called the instruction. So your program has the only such the instruction command. And what you guys need to do is to, by combining such a number of the instruction, you can use computing resource, processing power. That's what we're gonna do. But not many people, only few really there can directly use this one because it's not for human being, not for user. It's for the computer. So it's called the low-level language. Low level. So, but I understand the English. I understand the natural language. So instead, we are going to use high-level language, which is close to the natural language, human natural language, like the Java, Python, or the C++. It's for human being. It's for user. It's for developer. This one will be converted to the low-level language, then processed by the CPU. So this is called the compiler. So one part of the computer science, but which will not be covered in this class. So what we are interested in is the computer component, the CPU. So CPU can process this instruction. So sometimes we call something program as the thread. Why is it called the thread? Thread is the thread. Thread of what? Instruction. So CPU can process it at the instruction at a time. But it's a series of such an instruction. So because of that, it's called the thread. Okay, that is the CPU. So CPU is the main part because it processes the instruction. Instruction can represent what a user needs to do the program. But unfortunately, before that, how much fast the CPU is? The CPU actually, if you project a computer like my computer is a 3.6 gigahertz. What does that mean? So gigahertz, hertz means it's a frequency. So in 1 second, how many times? 3.6 gigatime frequency. Then what does that mean? So when CPU processes such an instruction, sometimes the CPU needs 2 clock. Because in computer there's no time like the conceptual level of time. So time is so fast, or this computer has their own time concept, which is called the timer. So that can be represented by only the frequency. There is no September, January, or the second or whatever. It's just a frequency. So in one in one period, it can process one instruction. Sometimes the one instruction, if that instruction is more complicated, it needs the 2 cycles. So for example, usually 1 point is less than 2 because some of the instruction need only 1 cycle, but mostly 2 cycles. So in this case, if on average 1 instruction needs 2 cycles of the CPU time, then the 1.8 instruction will be processed. Okay? The higher frequency, the better performance. So like that. So then, this is so fast, really fast. But it needs data. So CPU has something storage inside, which is called the register. So if you already took the microprocessor class, R1, R2 register, something like that. So this is a space. This is a kind of, for example, if a CPU is my desk, then this storage is like a drawer. So it's very convenient. So I can get my textbook from my drawer or the pencil my drawer, and after we A plus B, then it will be saved to the C like that. So very convenient. The problem is so small. I cannot put all the stuff in my drawer. So at that time, we need to have something cabinet on the right hand side. So CPU can read the data only from that cabinet is called the memory. So memory is the primary storage. So primary means it's not user point of view. From CPU, computer point of view, it's a primary storage. It's a storage much bigger than the register. It's like the cabinet over here. So then CPU can access the data only from this primary storage. Okay? It cannot actually access the file system. Why? Because it's so fast. But this one is too slow. So you may not get the full speed, the benefit of computer. So we can use such a memory as a primary storage. So this one is the most important part of the computer. But to speed up, to get the full benefit of the fast, we need to know about this guy. It's a memory. So before that, let me one about the CPU. So CPU, it has a storage, but we can access later. So we can get the data from the memory. So what is a memory? So if you see the cabinet like this, so cabinet has the like this. Then there is the first, second, third, and the first, the shelf, like this. Then it has something column like that. Actually, so if you go to the high-story apartment, so there is the first floor. This is not good. First floor, second floor, third floor, fourth floor, and it's 101, 102, 103, 104, and 201 like this. It's a high-story apartment. If you go to Manhattan or like downtown, you can see such a thing. So how can we identify the room using room number? So we can imagine, so like the 303 is the third floor and the third, the room like that. So memory is what? It's really array of address. Nothing else. It's just an array of address. Each address has what? It can represent 0 or 1. Using the electronic signal. So it can represent 0 or 1. So actually, if you search the Google, like the oldest memory or you can see like this kind of drum. And there is something spike over here. Do you know what is organ? Organ is like the music. So if you rotate this one, how can do you know how mechanism of the orb? It has something, the spike, like this, and then there is what is head or whatever. So when you turn, so you can touch, then there's a sound. So C, D, E, F. Then you can play the music, beautiful music like that. Exactly same thing. So you can't have the spike. This is 1, nothing. It's a 0. You can represent the data. This is the oldest version of the memory. Similarly, if we can represent the 0 or 1 using electric signal, 0, 1, 0, 1, 1, this is the data like this. So then, how can we access this data? Using address. So it has, so when we represent the memory, so 0, 0, 0, 0, F, 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 F. This is the address. There is much more than that. Like how can we store such a data? Little and big and such a thing. We are not going to cover that part, but we can have what we understand is we can put the data in this array of the address. Okay? Then CPU should able to access this data and bring to the register, like the cabinet. So I need the operating system textbook. So first we should know the address. Where is the operating textbook? Then it's 101 and go to first floor, first layer, then the first the room. Then get the operating textbook and put the first drawer. Because of that, the move is the most frequently used assembly. I think the most of the program, more than half is the move. So if you see the assembly code, it's move 1. Move from memory to CPU. And also CPU to memory. And register to register. So a lot of move, because it's not many space. So in and out, in and out. And the third data. So move is the most popular instruction code. So we can get such a data. From memory, CPU can only access this data. Through where? It is connected through the bus. Bus is kind of a highway. It's nothing but wire, really wire. If we have the wire like this, send the electronic signal. 0, no. 1, electric signal. 1, electric signal. Then they know 1, 0, 1, 1, like that. So this is the bus. If you are using 16-bit computer, how many wire? 16 wire. If you are using 64-bit, it's a 64 wire. Which one will be faster? Think of a highway. So Mary Parkway is a 2-lane, but I-95 is a 4-lane. So which one will be faster? And so I-95 is faster, like that. So definitely this one is faster. There are different type of bus. Data bus, send only data. Control bus, control signal will be sent. So it's connected through the bus. We have heard a lot of such a bus, like the USB, universal bus, right?
Signal bus.
Yeah, because it's a communication, but it's a universal, general purpose. It can be used for the mouse, it can be used for the storage, it can be used for any other thing, as long as they follow such a command, the regulation policy. So this is a bus. So through the bus, they can send and receive the data. So one more thing. This memory is good. It's fast and support the storage, main storage of the CPU. Problem? 2 things. One is expensive, and which means it cannot be really big. Second thing, it's a volatile. Volatile means if there is no power, it will be gone. It's not the permanent storage, not persistent. So because of that reason, we need another storage which is much bigger. Like the cabinet is convenient to keep the data what we need, but I cannot keep all the stuff like the 10 years before the textbook and so on. Instead, we'd better have the storage outside, storage room. So that is the secondary storage. secondary storage means, so from the CPU, computer point of view, primary storage is the memory, then it's not big enough and also it's not persistent, so we can store the data in the secondary storage. This secondary storage compared to the memory is much bigger, right? And also cheaper, and but slower. So for this the device, we have the basically two hard disk drive and the solid state disk. They are the different, the mechanical, the architecture. This one is using the
Rotating disk.
what is that? Kind of CD-ROM. Have you ever used the CD player to listen to music? Really? Wow. So it's old. Nowadays we are using MP3 or whatever, but this one, as long as we can keep the, where is that? 0 or 1, we can use as a storage. My first storage actually was the magnetic tape. So when I was a student, so like almost 30, 40 years before, so we used the cassette tape. It's a magnetic tape. So I'm not sure whether you have seen, but if you have a chance to ride the old car, like the 2000, before 2000, it has cassette tape. So actually I stored my first program into the cassette tape. If you turn on, so there's a really noisy sound. How? Because if you see your credit card, there's a magnetic tape. Magnetic tape has the information like the credit card number and the profile information. So using magnetic tape, we can represent the 0 or 1. So we can keep such a data using the hard disk drive. But this one, cheaper, but it's a mechanical, a lot, so we will see later, mechanical operation. So we can use the solid state disk, basically based on the memory. So we can keep the data on such a solid state disk. But this is a hardware, but in terms of a computer, we need something structure which is called the file system. NTFS, UFS, EXT, 2, 3, 6. So these are the software, the file system. Then, when we read the data actually from the CPU cannot read the data from here. Instead, we need to load this data on the hard disk drive or the file system to the memory. Then finally, CPU can read the data and process it over here. So because of that, we need to load the data from the hard disk drive to the memory. So this is called creating process. So sometimes my computer is very slow. So please check how many processes are running on your computer. Then what does that mean? Such a process, running process, how many? That means on the memory, how many programs are loaded into your memory. So if the memory is full of such a program, definitely it's a pack of the people. It's very hard to find the person who I need. It takes a longer time, same thing. Because of that, computer will be slower. So sometimes your program is something wrong. What happened? So keep communicating with the CPU. The other program, there is no chance to meet the professor. So one person is keep asking the question and the other student, there's no chance. Your computer is slow. We need to manage. So this architecture shows what we are going to learn in this semester. First, most important part, process. How to create the processor. Eventually, without process, the CPU cannot process such an instruction. So we need to know how to load such a program into the memory. Then how CPU access the instruction program. And how can we speed up? Process management. So first part is the process. Second part, this guy, the memory. Depending on how to organize the cabinet. So if cabinet is not well organized, it takes the time to find my data, right? So to find the textbook. So how to manage this one? This is called the memory management. So second part of this semester, we will see how to manage the memory. The last one is this guy. Even this part is it's a secondary storage. It's not primary, but so we can keep a lot of data. Actually, basically, whenever you are doing any operation, any job, any activity with your computer, your data will be eventually stored at the file system. So we need to know how the computer operating system is managing such the file, the data as a file. So these three process, memory and file system, three main components of the operating system. We are going to mainly see these three parts. Okay. Probably need to turn on. Yes. So, let me start here. So 12. Let me see any question from. I understand we cannot cover the whole the whiteboard. So using the webcam. So that's the reason Mohammed is taking the lecture. So you can watch the recorded video when available. So please understand the limitation of to show. If I'm familiar with to use the Zoom, I'm going to use. But it's not easy. But today, please excuse me. And from next class, I try to use the Zoom functionality to keep the lecture. Okay. So, anyone who?
I just went this morning, they still have the books.
Okay, so why don't you go to the bookstore and you can get, like the last semester, right?
I'm not sure. I just know that they currently said that they have the books in stock, so.
Okay, so why don't you go to the bookstore to get the book? And then if you want to purchase, the 9th edition is fine, but if you have the older, like the 8th edition, it's the chapter-wise, the organization was changed hugely from 8th to 9th. So 9th edition is fine, and 10th edition is the book that we are going to use this one. Okay. Any other questions? Okay, so one more time. So let me show you this again. Yes. Okay, so I'm going to divide the student into two groups. So group 1 can come to the classroom on Monday, and then the other group 2 can join the class using Zoom, and Wednesday it will be the changing. So group 2 can come to the class, and the group 1 can join the Zoom meeting. I will do my best to use the Zoom functionality, then those who are attending the class using Zoom can see all the information and so on. Then, but if you missed something, so please use the recorded video, which will be available by Friday or right after the class.
I will try to download it today or tomorrow.
Yeah,
maximum.
so same day was day after will be available. Okay, thanks so much for your joining. And the first priority is the safety. So please help me. Okay, thank you.